Hey students, now that we've got the magnitude down, let's talk about how to find the directional angle. Now you have done problems, you've seen them like this before on the left, where you're looking for a particular angle. In order to really get a feel for which angle you're looking for, you need to kind of imagine it on the coordinate plane. Because if 5 is your cosine and 12 is your sine, then you know that the angle that you're looking for, the reference angle, is always right here next to the origin. So knowing that, I can kind of get a feel for what I'm looking for. In reference to this angle, I'm given the opposite and the adjacent. So what uses the opposite and adjacent but the tangent? But we're not looking for a side length. Therefore, we don't use a tangent. We're going to use what we call the arctan. We're looking for an angle. So in your calculator, it looks like that. It's really called the arctan, which means what is the angle for the tangent ratio of these two sides. And so you say the tangent, arctan of theta is equal to 12 opposite over the adjacent. So with your calculator, you simply do second tangent 12 divided by 5. And you'll notice it's 67.38. Now I have my calculator in degree mode, so I gave it to you in degree. If I had it in radian mode, I would give it to you in radians, but right now let's just stay in degrees for right now. Now I've made it look a little more simple than it might be, because here's the deal. When you're talking about the tangent on your calculator, it really only considers from negative 90 to 90 degrees. It's going to give you these. Because a cosine is negative over here, you're going to have to do some adjustments if you get in this or this quadrant. And let me show you why. Let's say you're looking for this angle. So let's find vector k. It's at negative 4, 7. So if I go from the origin, which is what I'm going to have to do, there is my vector. And so I'm going to create a reference angle here. There's my 90, and here is theta. So this is negative 4, and this is 7, and I need this angle. So if you said the tangent, the arctan of that angle is equal to the opposite over this, and you actually put that in your calculator. So I'm going to do second tangent 7 divided by negative 4, and I'm going to get negative 60.2 degrees. Well, let me just make it negative 60.3 degrees. Now, as you know, negative 60 is about down here, right? What they've done is they're 180 off, because your calculator only knows from here to here. It doesn't realize that the negative is actually the cosine, not the tangent. It thinks you're down here. So what you have to do is, if you're in quadrant 2 or 3, you have to add 180 degrees. So if I had negative 60 plus 180, I actually have 119 degrees, 0.74. So this is my actual answer. So let me try that again with vector m. On vector m, it's 2 and negative 6. 2, 4, 6. So it's right down here. So as you can see, you are down here in the 4th quadrant. Now it reads this degree. It reads that down there. It knows where the x is positive. It just doesn't understand where the x is negative. So if I go, okay, this is 2 and this is negative 6. If I do tangent of theta, the arctan is equal to negative 6 over 2, which is, by the way, negative 3. Second tangent, negative 3. Then I get negative 71.6 degrees. And it is negative 71.6 degrees. So you can say that. But if you want to say it, you know, it is a negative degree. If you want to give it like this, then you would have to add 360. So negative 71.6 is the same angle as 288.43. So it knows where it's at. It's not where you have to add 180 because it's in the wrong quadrant. It's in the right quadrant. It's just not conventional to give me a negative degree angle. You have to add 360. So either one of those answers would actually fly. All right, let's go a little further. Oop, back up, back up. I wrote the directions down for the quadrants that I had done in that last example. So please make sure that you have those directions so you won't forget what to do. So now we can move on. What if you're given two different parts of the vector, namely the magnitude and angle? Can you revert that back to component form? And here's how it works. Now, sometimes they'll give it to you in polar form. They'll say 6, 45 degrees. The fact that you see degrees here and a number there means that this is in polar form. This angle has a magnitude of 6, but it's at 45 degrees. So how do you figure out what the component is horizontally and vertically? It's pretty simple. I know where it's at, so I know that I have two positives here. All I have to do at that point is take the magnitude times the cosine of this. So I'll say 6 times the cosine of 45 degrees, and then I'll find 6 times the sine of 45 degrees. So it's going to actually give me that value, and I just put it in component form. Make sure you're in degree mode, and you hit 6 times the cosine of 45, and in this case it gives me 4.2. I'm just going to leave it in tenths. And then I do 6 times the sine of 45, and it's 4.2, which makes sense. The sine and the cosine are the same thing on 45 degrees, yes? Isn't the sine of 45 degrees 2 times the square root of 2? Oh, I'm sorry. It's 2 over root 2. Root 2 over 2, I'm messing this up. Root 2 over 2. That is the cosine and sine at that angle. You're just taking 6 times that. That's what's happening. All right, let's try another one. Suppose they tell you, okay, the magnitude is 3 and the angle is 115. I want you to first figure out where that is, because you have to worry about the negatives here. 115 is about right here. It's right. And I wished I had used something besides 115, because that's, well, it doesn't matter. Here we go. So all you have to do is say, okay, I know that my x-coordinate, the cosine, is going to be negative, and my y-coordinate is going to be positive. So just in case that doesn't happen that way, I need to make it happen. So I'll take 3 times the cosine of 115, and then I'll do 3 times the sine of 115. And let's see what I get. 115, by the way, is 90 plus 45, so I'm down there in that same region, if you will, the same ratios. So this, the cosine, oh, it gave me a negative, that's good. Negative 1.27. Oh, it's a vector, right? So there's my horizontal component, and the sine is 3 times sine of 115, and it's 2.2. So there we have it. You just have to use these. Now, if it wants I and j, I would have said negative 1.27 I plus 2.2 j if it wanted in linear combination form. Okay, we're at 9 minutes. You guys take care.